Hey guys, my name is Reno, and today we're going to be looking at the perimeter and area in the coordinate plane. So the first topic, polygons. Before we go into the actual topic of the polygons, we need to look at the definition of it. So, a figure that lies in a plane is called a plane figure. We need to know this in order to understand the definition of a polygon. So what it says here is that a plane figure is any figure that lies in a plane. So, now moving on to the actual definition of the polygon. A polygon is a closed plane figure formed by 3 or more line segments called sides. So 3 line segments would create a triangle, 4 a quadrilateral, 5 a pentagon, and then so on and so forth. So a polygon needs to be closed in order for it to be called a polygon, and it also has to be a plane figure. Next, each side intersects at 2 other sides, each one intersecting at one vertex. So this point I'll go in depth in the next slide where I want to show you a picture. So after that you'll understand this. So finally, how we can name a polygon. We can name a polygon by listing all the vertices of, so for example, A, B, and C for a triangle in consecutive order. Then the name of the polygon would be triangle ABC. Alright, now next topic, convex or concave. So convex, this is when all the interior angles of a polygon is less than 180 degrees. So this is what it would look like. As you can see, none of these angles are greater than 180 degrees. They might be obtuse and greater than 90, but none of them are greater than 180. So now I said that I would cover a topic earlier, which was the intersection of each side to other sides and the intersection at each vertex. So I'm going to explain that to you right here in this diagram. So as you can see, this one side, for example, it intersects at a point right here. So this is what you like to call a vertex, and this is the vertex. This side intersects with 2 other sides right here and here. And you can see that that's what happens to all the other sides here. Now we can move on to our next definition, concave. When one or more interior angles are greater than 180 degrees. So as we saw here, there are no angles greater than 180 degrees. But here, there's one angle greater than 180 degrees, which makes this a concave polygon and not a convex polygon. Okay, so here's some convex or concave practice for you guys. So all you need to do is determine if these shapes are convex or concave, and I want you to write down how many angles are greater than 180 degrees if they're concave. Pause the video. These are the shapes. Pause the video, try this out, come back, and I'll give you the answer. Alright, now that you're back, let's find out the answer for this. So for the first one, this angle is not greater than 180 degrees. This is acute. This is obtuse, but not greater than 180 degrees. Obtuse, but same case. This is acute, obtuse, but still smaller than 180 degrees. But right here, this is greater than 180 degrees and almost hitting 205, 210 degrees. So this is going to be concave with one angle greater than 180 degrees. Next shape. This is here you can see that there's one obtuse angle and almost one right angle and 2 acute angles. So this is a convex shape because there are no angles greater than 180 degrees. Next, so this is acute, this is acute, this is obtuse, almost reaching 180 degrees but not quite. This is good. This is acute, this is obtuse. This is angle greater than 180 degrees, which already tells us that this is concave. But since we need to count how many angles are greater than 180 degrees, let's keep going. This is acute, and this is greater than 180 degrees. So this is a concave polygon with 2 angles greater than 180 degrees. Alright, next, types of polygons. So as you might have heard, triangle, quadrilateral, pentagon, hexagon, all these different shapes, they're all types of polygons according to the number of sides they have. So for example, if there are 3 sides, triangle, 4 sides, quadrilateral, 5 sides, pentagon, 6 sides, hexagon, 7 sides, heptagon, and 8 sides, octagon. There's still more. 9 sides, nonagon, 10 sides, decagon, 11 sides, hendecagon, and 12 sides, dodecagon. But these two, 11 and 12, you're not really going to need to memorize this. Well, up to 10 would be a good idea to know all of them. You might need to use them. But 11 and 12, there's going to be very rare chances of you using it. But we could keep going on forever and ever because there are infinite amount of numbers. So how are we going to represent that? For example, if there's a really, really high number, for example, 1,000 sides, how are you going to name it? So for that, there's a letter N, which represents the number of sides. So it's just going to be an n-gon. For example, the 1,000-sided shape, it'll be 1,000-gon. Sounds kind of weird, but that's how we name it. Alright, number of sides. So this is all you're going to want to do here is determine the name of the shape according to the number of sides. So these are the same shapes from earlier. You're just going to write down the name of the shape according to the number of sides. Pause the video, try this out, come back, and I'll give you the answer. Alright, so we already discussed the concave, convex, and the other concave. Now to look at the name of the shape according to the number of sides. In the first figure, there's 1, 2, 3, 4, 5, 6 sides, which means that this is a hexagon. Here, there are 4 sides, 1, 2, 3, 4, which means this is a quadrilateral. And in the final one, there's 1, 2, 3, 4, 5, 6, 7, 8 sides, so this is an octagon. Alright, now moving on to the bulk of our chapter today, or our section today. Perimeter and area. So, first, the triangle. So this is how the triangle would look like with height h and sides A, B, and C with a right angle at the meeting point of H and B. So the perimeter is just going to be the sum of all the sides together, summing up all the sides, and then the area is going to be 1/2 base times height. Now to take a look at the square. So this is a square. These lines represent or says that all sides of the shape are equal or the same. So the perimeter is going to be 4s. As we can see here, s represents one side. Since we know that all 4 sides are equal, 4s, you're just summing all of this up. You could write s plus s plus s plus s, but a simplified way to write this is 4s. Next, the area is going to be s squared. You're just going to multiply 2 of these sides together to get the area. Next, to take a look at the rectangle. So these single lines represent that these 2 sides are equal, this side and this side. These 2 lines represent that this side and this side are equal. There's a right angle at each intersection between the sides. It creates 90 degrees. The shorter side is the width and the longer side is the length. So the perimeter is going to be 2 times length plus 2 times width, and the area is going to be length times width. Alright, now to go on with 2 more word problems. There's only 2 more questions that you need to complete, and then you're going to be done with the lesson today. So first, finding the perimeter in the coordinate plane. Find the perimeter of triangle ABC with vertices A, negative 4, 3, B, 5, -4, and C, -4, -4. Plot these points. Try to find the perimeter with everything that we've learned before in the previous videos. We learned about the ruler postulate, distance formula, midpoint formula. Use all of these and try to find the answer. Come back and I'll give you the final answer. Alright, now that you're back, first I told you guys to plot it. So we have our graph right here. So this is going to be point A at -4, 3, and then we have point B at 5, -4, and then we have C at -4, -4. We're just gonna connect all of these sides together, which gives us a triangle. So first, let's start off by finding the length of side AB. So here it's not a straight horizontal or straight vertical line, so we're gonna use a distance formula to solve for this. So the distance formula was AB, the side right here, is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So since we're looking at A and B, our x2 is going to be 5 and our x1 is going to be -4. Our y2 is going to be -4 and y1 is going to be 3. So let's when we plug in our values, we get the square root of 5 minus negative 4 squared plus negative 4 minus 3 squared. And then when we add all of those numbers up, the negatives cancel here, so we get 5 plus 4 squared, and then these negatives sum up together to get us negative 7 squared. We're just going to add our 5 and 4 to get 9. Then we have 9 squared plus negative 7 squared, which is going to give us 81 plus 49. We add both of those up to get 130. The square root of 130 is approximately 11.40 units. Next, we're going to find the length of side BC. So as we saw earlier, side BC is completely horizontal, so we can use the ruler postulate for this. So the ruler postulate was BC is equal to the absolute value of x2 minus x1. We still have our coordinates right here, so BC, x2 is going to be negative 4 and x1 is going to be 5. So when we plug in our values, the absolute value of negative 4 minus 5, we get the absolute value of negative 9, which gives us BC is equal to 9 units. Next, side AC. Side AC, as we saw earlier, was completely vertical, so we can use AC is equal to y2 minus y1 and the absolute value of that. So A and C. The y2 is going to be negative 4, y1 is 3. When we plug in our values, we get negative 4 minus 3 and the absolute value of that. AC is equal to the absolute value of negative 7. Then AC is equal to 7 units. Now we need to find the total perimeter. So the total perimeter, as we saw earlier, was just the sum of all the sides of a triangle. So we're going to add up AB plus BC plus AC. So AB was 11.40, BC was 9, and AC was 7. So we're going to sum all those values up to get the perimeter of 27.40 units. Our final problem, finding the area in the coordinate plane. To find the area, so what you're needed to do is to find the area of triangle ABC with vertices A, negative 4, 3, B, 5, negative 4, and C, negative 5, negative 4. You just need to find the area of that triangle plotted. So, plot these points on a coordinate plane. Find the area of the triangle. Try your best. Go look at the formulas that we've learned so far about the triangle, square, rectangle. Use our distance formula, ruler, postulates, whatever you need, and then come back for the final answer. Alright, first I told you guys to plot the points, so let's take a look at the coordinate plane right here, and then we're gonna plot the points A, B, and C. A and B did not move from our previous problem, but C did move. It was negative 4, negative 4. Now it's negative 5, negative 4. So this does not give us a right triangle, but it gives us a certain triangle. So first, to find the area, we need to find the length of the base. So base is the BC. So since this is a completely horizontal line segment, we can use BC is equal to x2 minus x1. So BC, x2 is negative 5 and x1 is 5. So we can subtract negative 5. It's going to be negative 5 minus 5, which gives us the absolute value of negative 10. So the final value is BC is equal to 10. So now to find the height of the triangle. Here we don't really have a perfectly vertical line segment, as you can see here. This is diagonal. So in order to find the height of this, when you're not actually certainly given a vertical segment, and you plotted it on a coordinate plane, you can count the grid lines right here, the grid lines. So as we can see here, the grid lines says 1, 2, 3, 4, 5, 6, 7. So there are 7 grid lines from the point A to base BC. So that says that the height is 7 units. So now we need to find the area of triangle ABC. In order to find the triangle in the area of a triangle, we know that it's 1/2 base times height. So we know the base and the height, so we can solve for the area. It's going to be area is equal to the 1/2 base times height. It's going to be 1/2 10 times 7, 1/2 times 70. So the final answer is going to be area is equal to 35 units squared. You're not given feet, meters, or anything here, so you're just gonna write units squared. I hope this video was informational for you guys.